So, once again, you're writing this right on the worksheet because the worksheet's going to be your notes for the day. The key today is distance. We are talking about...
Addison Hope to the office, please.
Your Hoke now. Alright, got it. So, it is the absolute value of the difference. One of the things that I like about Engage New York, it is forcing you to become better readers. Almost every single problem that we've had with Engage New York is a word problem. Like, think about our tests. There's very few tests that we have that say 7 minus 17 or 7 plus a negative 17. That's not what our tests look like. They're giving you a full question that you're having to break down the words and understand them. The problem is, our reading comprehension's not all that great yet, especially when it comes to mathematical language. So this is the formula or the definition that I want you to use for distance. It's the absolute value of the difference. But let's break it down a little bit more. What is the difference? Like, I want a nice specific definition for difference. Kennedy. I can't hear you because of this fan. Okay, there you go. So difference is the answer to a subtraction problem. Do we all agree with that? So we know difference. We are going to be subtracting. What is absolute value? Good, man. Distance from zero. Liam, what do we know about absolute value?
That it's always positive.
Oh, so this is always positive. This is the answer of a subtraction problem. So I'm going to rewrite this a little bit different. I'm going to say the positive value of a subtraction problem. And that might make a little bit more sense. If we're dealing with the positive value from the subtraction problem, that might make a little bit more sense. So we're actually picking up our pencils and we're writing down this definition because I think I said, I'm old, I'm forgetful, but I think I said these are going to be our notes today. Is this worksheet? Oh, yeah. Again, I've been hitting the head a lot. Like those boxing matches took their toll. So I never know if I'm remembering or not. Yay. Micah, thank you for the thumbs up. I appreciate it, buddy. Micah, choose a number. Still a crappy number, Mike. You're always going to be wrong, Micah. It's not going to matter. So, absolute value. So, how else can I do this? So, I'm finding the distance between these two. So, there are two ways. I can show this as the absolute value of 7 minus. This is my subtraction problem. And this is where, listen, I have screwed up a couple times today. I've had to go back and fix it. It's 7 minus what? So, I should see hands. What are we taking away from 7? Micah, choose that number right. Don't screw it up, Micah. Beautiful, brother. It's 7 minus negative 17. So now I have the absolute value of 7 minus a negative 17. I'm telling you, you're going to see problems like this today. Forget about the absolute value. The absolute value just is hanging there until the very end. Hi, Addie. Welcome back. Okay? It's hanging there until the end. So now we're looking on the inside. The opposite of a negative. What's the opposite of a negative? I should see. Go ahead, Ava. Ava's like, woo! Ava's got it already. Go. It's a positive. So now I'm going to rewrite my problem inside of my absolute value. 7, that becomes a positive 17. Again, this we can do. So now I have the absolute value of 24. That equals 24. Okay, that's showing me the difference. But is that the only way that I could do it? No. So copy this down. I'm going to erase this all in a second. We good here? Yes, yes, yes. Stop. Okay. Yes? So the other way that we could do this is it doesn't matter. For distance, the order does not matter. So I could say the absolute value of negative 17 minus, Micah, choose a good number. So if the order doesn't matter, it's negative 17 minus what this time? 7. Okay, you're 2 for 2 now. Except for that first one stunk it up, Micah. It's bad. So 17 minus 7. Again, I'm only worried about what's inside. Absolute values are a grouping symbol. So if you get an order of operations problem and you have absolute values, you're doing what's inside of it first. We know that when we have a subtraction problem, I can circle my terms. Those are the same signs. So that means I add them. 17 plus 7 is 24. I put the original sign back with it. Gives me negative 24. But again, distance is the absolute value of the difference. That's why we had the absolute value beginning with. So now I'm ending up with 24. So I know that the change, the temperature decrease, is 24 degrees. That way we can now say Monique is correct. Questions there? Okay, I'd flip that worksheet over. So today all we're concerned about is the distance. So, what is the distance? You seeing that? I hope so. This coffee is horrible. No, I'm blaming. No, don't go ask her why it's bad. Why would I want more? It's horrible, Addie. You have one job. It was to go get me good coffee. Do I want a cookie? Yes. No, like coffee shouldn't be see-through. Like it's mud. Ah. Okay. As long as it has caffeine in it, it probably doesn't matter. So, what is the distance? Let's start off nice and basic. We're going to do this the easy way first, and then I'll show you the harder way. So, what is the distance between negative 3 and negative 1 1/2? So, we're just finding the distance, okay? Most of you would say, hey, I know the distance is the absolute value of the difference, because I just taught that to you, so that would be a good thing to say. But let's pause for a second. Let's make this easy on ourselves. I'm going to pretend that this number line is under a magnifying glass and make it pretty big. So we've got 0, we've got negative 1, we've got negative 2, we've got negative 3. Come on. What I want you to get in the habit of when it's asking for distance on the number line, you're not drawing arrows, okay? Because we're trying to find out what's in between two things, the distance in between them. So, I am going to start by putting a point, I'm plotting the point directly on negative 3. But it says negative 1 1/2. If 1 1/2 is there, everything needs to have a half. What do I mean by that? Well, between 0 and negative 1, there needs to be negative 1/2. Between negative 1 and negative 2, there needs to be what? Raise your hand. What's going to be between negative 2 and negative 1, kid? Very good. Negative 1 and 1/2. Between negative 2 and negative 3, Jamie?
2.
What? What?
Negative.
Oh, okay. Negative 2 1/2. So now we can plot our other point. So now that I've put the halves in there, I can now plot my point. Everybody still with me? Let's change colors because I can. So it does not matter which direction you count from. Drew, do you want me to count from the left to the right or the right to the left?
Right to the left.
Right to the left. Okay. So here's going to be our problem. A lot of you will get this point and count to this. Is that a full unit's worth of measurement? No, because that's only what?
Half.
A half. So we don't want to count that half right away. So when we're counting this, we're going to go from negative 1 1/2 to negative 2 1/2. So there's one full unit. Everybody with me there? But have I gotten to that point yet? So what do we still need to add or count? Go ahead, Drew. Finish. A half. So that's my 1/2. So the distance between is 1.5 units. Okay? Very easy with the number line. Very easy with the number line, yeah? Could we make this really difficult on ourselves? Absolutely. Could we say -3 minus -1.5? Absolutely. Because we know the distance is the absolute value of the difference. There's my difference, there's my absolute values. Now we would need to simplify it. So I'm going to kind of do this a little bit quickly. I got -3. The opposite of a negative is positive 1.5. Now I've got -3 plus, this is going to be 3/2. Well, -3 over 1, we need to multiply by the other denominator, which is 2. -6/2 plus 3/2. We know my denominator has to be 2. -6 plus 3 is -3. Absolute value of -3/2 is, what are you doing this week? Positive 3/2 or 1 1/2. So, I ask you, because most of you can't do it that quickly. Most of you can't. I'm amazing. I know. It's fine. You're welcome. You're welcome. It's kind of like the song from Moana where he just talks about himself. He's like, hey, I'm pretty awesome, aren't I? You're welcome. Like, that's me. Like, I could be that guy. I've never actually seen the whole movie, but I've seen that song, and I'm like, haha, he's got an ego. So, would we rather do this or a number line? Like, I'd personally rather do the number line. If you want to do all this work, hey, go for it. More often than not, if it gives you a number line, plot the points on there and count. Everybody with me? This is the lesson today. We're not really doing anything different besides the last step is finding the absolute value. That's how we do distance. So I'm done. Yay.